Question 4. A particle P of mass 3m is moving in a straight line on a smooth surface on the floor. A particle Q of mass 5m is moving in the opposite direction to P along the same straight line. The particles collide directly, blah blah blah. The speed of P is 2u, the speed of Q is u. The coefficient of substitution is e. Show the speed is that, and find the value of e, which is not changed. So, only one thing to do, draw a picture. Here's P. P has a mass 3m and is going in that direction with speed 2u. Here's Q. Q has a mass 5m and is moving in the opposite direction with speed u. If we read a bit further, it does say the directional motion of P is not changed as a result of the collision. So after the collision, P's still going in the same direction. So that one's obviously going in that direction after the collision, and we don't know either of those speeds, so we'll call this one V. And we'll call this one W. And E is equal to E. So we don't know what that is. And that's pretty much the picture drawn. We could have assumed that they were bound and B is going the other way, but since a small amount of reading tells us that's not what happens, we don't bother. So now we do our two things. Firstly, the conservation of linear momentum. So if we work out the momentum before, we'll take that as the positive direction. Then we've got 3m mass times velocity plus mass times velocity before is equal to mass times velocity plus mass times velocity afterwards. Bit of cancelling of all the various m's. 6u take 5u is equal to 3v plus 5v, vw, because that's, I can't read my own thing. So that gives us that u is equal to 3v plus 5w. There's one equation. And now we also consider the restitution, which is E. So that's going to be the difference in speed afterwards, w minus v, over the difference in speed before, 2u minus u, w minus v over 3u, or if we rearrange that, w minus v is equal to 3eu. So there we go, we've got two equations. There we've got equation 1, u is equal to 3v plus 5w, and that's from the linear momentum. And from the restitution, we've got w minus v is equal to 3 EU. It probably pays now to try to remember what we're actually trying to work out. Show the speed of Q. The speed of Q, we're trying to find W. So that's what we're trying to find. Let's make a little note it to ourselves. We're trying to find W. We need to solve those equations to find W. Oh, we can certainly rearrange the top one. And we could rearrange the bottom one. How about the bottom? So if we take the bottom one, W is equal to 3 EU plus V. If we look at the first equation, we can write that as V is equal to a third of U take 5W. We can then write it as W is equal to 3 EU plus a third lots of U minus 5W times the 3 out. 3W is equal to 3 EU plus U minus 5W. Add the 5W on, 8W is equal to 3 EU plus U. Factorise the right hand side, U. Oop, that should be a 9 because I times that by 3, didn't I there? Always be careful, don't make silly mistakes. U, 9E plus 1, divide by 8 EU. W is equal to U over 8, 9E plus 1, which was the result that was required in part A.